Okay, so today we're going to talk about equations and inequalities. Um, and so we're going to start off with the homework answers from last time. So if you haven't, if you've done the homework and you want to check your answers, feel free to pull out your homework so that you can check your answers. But these are the answers to the homework, and then I'll quickly go over to explain them in a second. But I'm giving this as an opportunity so you guys can just write down the homework answers so that you can check. Thank you. Okay, so I hope you guys have had a chance to write it down. And it's okay if you haven't. I'm going to go to the homework so I can explain them, but then we can go back to the slide afterwards if you guys have any questions or anything. So yeah. Okay, so at the homework, this is the homework that you should have done. So the first one, for the first problem, it's pretty simple. You just want to turn this into fraction form like we talked about last time. So from here, we can kind of go into fraction form. This is just 625 over 1,000. And then if we divide by common factor of, let's say, well, 625 over 10,000 or sorry, 1,000, and then you can simplify this, which this ends up just being 5/8. So you can divide by 125. 125 goes into 1,000 8 times, and 125 goes into 625 5 times. So yeah. And then this one, again, it's pretty simple. You want to say that this is just 70 over 100 because you can multiply 10 to the top and 10 to the bottom. So then you get 70 over 100, which equals 70%. For question 3, the tip, this is kind of a word problem. If you have a 15% tip, then you just multiply 24 times 0.15, and that should equal $3.6. Because 15% equals 15 over 100, which also equals 0.15. And then you can multiply. And then for this one, I think the easiest way for me to visualize it is I did 3/5 and I converted it into decimal form. So 3/5 in decimal point form is you can go from 3/5 to 6/10, and 6/10 is just 0.6. And 0.6 is greater than 0.58. So yeah. And then 25% of a number is 12. So what is that number? So we know that some number times 25% is 12. So that number equals 12 divided by 25%. And 12 divided by 25% is equal to 12 divided by 1/4. So then, that's just 4 times 12, which equals 48. And then this one, this is just saying 36 out of 45. What's the percentage? And you can simplify that. If we divide by 9, then you get 4 over 5. For 36 divided by 9 is 4, and then 45 divided by 9 is 5. So then that just equals 4 over 5, which equals 8 out of 10, which equals 80%. Now for this one, we can see that 40% plus 30% is 70%. And since the rest are yellow, that would mean that 100% minus 70% is 30%. So 30% are yellow. If there are 90 candies, then that would mean that you multiply 30% times 90, which equals 27. And then for question 8, this is just, so the original cost plus 20% of the original cost is $54. So that would mean that 120% of the original cost is $54. So 54 divided by 1.2, which is 120% in decimal form, should just be 45. But that's a quick review of what homework is. Does anyone have any questions? Raise your hand if you do. And yeah, if I haven't graded your homework, I'm so sorry. I'm gonna be out, and I've been out, so I'll grade your homework as soon as possible, but it's gonna take a couple of days. So yeah, this is still the answers in case anyone wants to write them down. but I'm assuming that you guys don't have any questions. So then we're just going to move on to today's topic. And today's topic is on equations and inequalities. So we'll start off with equations. Equations are kind of on the it's like the easier a bit. So the definition of equation is an equation is a statement where two expressions are equal. So one side of the equation is the expression. So it must contain an equal sign. So for example, 3x plus 5 equals 14. 3x plus 5 is the left side, 14 is the right side. So how to solve this, and this is variables, okay? X over here is the variable that you're trying to solve. So 3x plus 5, and then you minus 5 to both sides. So then you get 3x equals 3x plus 0 equals 9, right? Because if you add the same thing to both sides, it's still equal. Like if you have 5 equals 5, and you add 5 to both sides, then 10 equals 10. So then you go 3x plus 5, and then you minus 5 to get rid of this 5 over here. And then, but if you minus 5 on one side, you have to minus 5 on the other side, so it's 14 minus. So then 3x equals 9. And then 3x equals 9, well then how do we get rid of the 3? Well, if we multiply 3, then the only way to get rid of the 3 is if we divide by 3. So we divide both sides by 3 to get, so then you have 3x divided by 3, 9 divided by 3 to get x equals 3. So that's kind of an example of how to do it. So the kind of key idea here is the goal is you want to find the value of the variable that makes this equation true. So what number for x, which is the value you want to know? Like what value of x would make this equation true? So 3 times what plus 5 equals 14? Well, 3 times 3 plus 5 is 14. So you want to think of this as like a balance scale where both sides kind of have to stay equal. That makes sense. Does anyone have any questions? Okay, if you have any questions, feel free to raise your hand at any time or put it in the chat. But yeah, if you guys don't have questions, I can move on. But if you have any questions, feel free to type it out or raise your hand. So that's the very basics of what an equation is. Well then, now we want to kind of solve equations. So sometimes for an equation, there can be multiple steps to solve it, but we're going to start easy. We're going to start with just one-step equations. So how you want to do this is you want to identify which operation is done on the variable, whether it's addition, subtraction, multiplication, or division. And then you want to use the opposite or the inverse of this to isolate the variable. So you want to keep the equation balanced by doing the same thing to both sides. So for example, we can see x plus 7 equals 12. This is an equation, right? So we can see that this is addition. You are adding something to the variable. So what's the opposite of addition? Well, the opposite of addition is subtraction. So you want to subtract 7 from both sides. And you have to subtract from both sides so that you get x equals 5. Now for the second example, it's 5x equals 20. Well, let's first identify the operation. The operation used over here is multiplication. So that's 5 times x equals 20. So how do we get rid of this constant and find what the variable equals? Well, you want to divide both sides by 5. So then you divide 5x by 5, just equals x, and then you want to divide 20 by 5, which equals 4. So those are just two examples of solving these one-step equations. These only require one step where you either need to add, subtract, divide, or multiply. That's it. And then some common mistakes to avoid is like forgetting to apply the operations to both sides or mixing like inverse operations. Those are some pretty common mistakes that are made. But just make sure that whatever you do to one side, so like the left side, the side of the variable, you also have to do to the right side. So if you subtract 7 from the left side, you have to subtract 7 from the right side. and then you have to make sure you know the inverse operation. So you want to identify what the operation is. So if you're multiplying x by something, the variable, then you want to make sure that you know that the inverse is dividing. Or if you're adding, the inverse is subtraction. And like if you subtract, the inverse is adding. If you divide, the inverse is multiplying. But yeah, that's some key things that you want to make sure you don't forget. Does anyone have any questions?
Can you repeat like what you were saying for like the examples, because I couldn't like hear you that much.
Okay, yeah. So basically for the examples, for 7, x plus 7 equals 12, right? We can see that the operation is addition here. It's x plus 7, so you're adding a number. The number that you're adding is 7. So in order to kind of solve this, we want to make sure x is on itself, right? We don't want to have any numbers next to x, so we can find out what x equals. So what you want to do is that since we defined that the operation now is addition, we want to use the opposite of addition, in this case subtraction. So we want to subtract the number 7 from both sides, right? Because if you have x plus 7, then minus 7, then that just equals x plus 0, right? But if you minus 7 to one side, you want to make sure it's still equal, right? You have to minus 7 to the other side. So then you have x plus 0, which equals x, equals 12 minus 7. And then 12 minus 7 is just 5. So that's how you get to x equals 5. Then, for the second, does that make sense?
Yes, thank you.
Okay. And then I'm just going to put this in the second one. So for the second one, you have 5x equals 20. This is 5 times x, right? So the operation here is multiplication. So how do we get rid of multiplication? Well, in order to get rid of multiplication, you want to divide, right? So the opposite of multiplication is division. So we want to divide both sides by 5. So we'll start off with the left side, right? 5 times x. Well, then we divide that by 5. So instead of 5 times x, you have 5 times x, then divided by 5. And then that just equals 1 times x, right? Because 5 divided by 5 is 1. So then 1 times x is just equal to x. Now for the right side is 20, right? So we have to divide both sides by 5. So we have to do 20 divided by 5. And 20 divided by 5 is 4. So then that's how you get x equals 4. Okay, does anyone have any other questions or anything else that they want to clarify? And it's okay if
Can
you
you
do.
explain that again?
Which one? Second one? Or,
Yeah.
Second one?
Mhm.
Okay. So I'm going to write this out because it looks easier when you write it out. So let's see. You have 5x equals 20, right? Well, in order to get rid of the 5, right, you want to make sure that the variable is on its own. I'm just going to write this out. Okay. So then how do we make sure that the variable is on its own? Well, we can divide both sides by 5, right? And remember, you have to do this operation to both sides. Because we are multiplying here, so the opposite of multiplying is dividing. So then, since we're multiplying both sides by 5, we're multiplying 5 by x, right? So we want to divide by 5 to kind of get rid of it. So then we can see that that just translates to 1 times x, because 5 divided by 5 equals 1. So that's 1 times x. X. And that equals 20 divided by 5. And 20 divided by 5 equals 4. And then 1 times x, because 1 times any number is itself, right? So then 1 times x is just equal to x. So that's how we find x equals 4. Does that make more sense? Or is there like a specific part you're confused on that you want me to explain?
I don't get the end.
Huh?
I don't get the end.
Like the 1 times x part?
Well,
Or x equals 4?
can you just like explain the like that
Okay.
end again?
Do you understand why we're dividing by 5? Okay. So then if you understand why we're dividing by 5, then you understand that the left side just equals x, right? And the whole goal of solving an equation is to find this missing value. Like, what is this value of x? We don't know what that is. So then if we do the math on the right side, then you get x equals 4. And you can kind of check this, I guess, in a way, because we have 5 times x, right? 5 times some value equals 20. Well, then if we plug in 4 for x, right, we see that 5 times 4 does actually equal 20. So you kind of did that right. Like, you can think of it this way of you're trying to find what number makes, like, this equation true, and this equation being the original equation. Like, what number of x makes this true? 5 times what number equals 20? Well, we know 5 times 4 equals 20, but this is kind of showing how you get to 4, right? Like, if you have a much bigger number, like 5 times x equals, like, 1,000, you don't just know off the top of your head that, 5 times 250 equals 1,000. Like, you have to solve for it. And how you get that is you get 1,000 divided by 5. So basically, it's trying to find what value, 5 times what value equals the right side number, essentially. And in this case, you know why we divide both sides by 5. So then we can see that 20 divided by 5 equals 4. And then we get that x equals 4. Make more sense? Okay, good. Does anyone have any other questions? Could be about this or could be about anything. Okay, I think we're good. But if anyone has any lingering questions or if something still doesn't make sense, you can always just type it in the chat or you can raise your hand, unmute yourself. And it's okay to be like confused. This can be very confusing initially. So yeah, you guys are doing a really good job. So now that we've gone through some examples, we should practice this, right? So all of the letters here are variables. So in this case, right, y is a variable. M is a variable, P is a variable, K is a variable. And what you want to do is you want to find these variables. What does Y equal? What does M equal? What does P equal? And what does K equal? I think I'm gonna give you guys a minute so that like everyone can find the answer to these questions. And when you're done, you guys should raise your hand if you have an answer for all 4 of these, and then I'll have someone explain each question. But I'll give you guys like a minute. I want to have as many people be able to do these as possible. So yeah. You guys have a minute to practice this. And then we'll go over the answers in a second. No, it's okay if you don't want to raise your hand. Or if you don't want to explain, but if you do want to explain, like raise your hand. And then I'll call on you guys in the order that you raise your hand. And then I'll try to have as many people speak as possible. Okay, I think most people are done. Does anyone want more time to work? And it's okay if you do.
Can I get more time, please?
Yeah. How many more minutes do you want?
Can I just get like 5 more minutes?
Yeah.
Thank you.
Okay, no problem. Just let me know when you're done. So I want everyone to be on the same page. Okay, who is the person who asked for more time? Because I didn't see your name. I just want to make sure.
It was me.
Okay. How far are you to being done?
I'm on the 4th problem.
Okay. Do you mind if we explain like the problems and like we'll
Yep.
go over?
That's okay.
So just in the order of people who raised their hand, Darlena, do you want to explain the first problem?
Is the first problem 13 because 9 plus 4 equals 13?
Yeah. Okay, that's a good job. So you add 9 to both sides because we see that the operation is minus, right? So then if we add 9 to both sides, then you get y equals 4 plus 9, which equals 13. So that's correct. Okay, so do you want to explain the second question?
Yeah. So 6m equals 42. So you divide by 6 on both sides, which equals to m equals 7.
Yeah, exactly. Okay, good job. Tanisha, do you want to answer the third problem?
Sure. You multiply both sides by 8, and on the p divided by 8 sides, the 8's cancel out, and then 3 times 8 is equal to 24. So p is equal to 24.
Okay, perfect. And Priya, do you want to explain the fourth problem?
Yeah. So first, it says k plus 2.5. So I just minus 2.5 on both sides. So I got 4.6.
Okay, yeah, perfect. So these are the answers if you want to see. Evelyn, do you have a question?
No, I'm okay. Thank you.
Okay. Yeah, so these are all the answers. And those explanations were really good. So good job. Does anyone have any questions about these explanations, the answers? Or did you guys like get something different or you don't understand anything? Okay, if no one has any more questions or something, then we'll move on. But if you still have a question and you don't want to ask, then you can always chat.
I only have one here, but
Wait, can you just go back to the slide, the question slide, so I can just copy them down so I remember them?
Yeah, no problem. Sorry, give me a second. Here are the question slides.
Okay, thank you.
No problem. I'll give you a minute to copy them down. And then, Also, today's gonna be a shorter class, just because. I think it will be, at least, because I didn't do a confused for breakout rooms or anything. Well, partially because I've been busy, but yeah, today's just gonna be a little bit on the shorter side. But we'll still have practice problems, and if you have any questions, feel free to ask.
I'm done copying. Can you go to the next slide?
Perfect. Yeah, this is the answers if you want to check. But these slides will also be posted on Google Classroom. So, you know, if you always want to check, you can always go back. But with that being said, I'm going to move on to two-step equations. So we just covered one-step equations, right? That one you only needed to do one operation. You either needed to multiply, divide, subtract, or add. Only one operation, right? But now we're going to move on to two-step equations. So this is an equation that requires two different operations. So, you might have to subtract and multiply, or, divide and add. So how do you do this? Well, the first step is when you have something, like when everything's just kind of written out straight, there's no parentheses, you want to undo the addition or subtraction first, and then the second step is to undo multiplication and division. So let's look at this example. We have 2x plus 5 equals 17. Well, what's the first step? The first step is not dividing by 2. We want to get rid of the addition, right? And the addition here is we're adding by 5. So how do we get rid of it? We subtract 5 from both sides. So you get 2x equals 17 minus 5. So 2x equals 12. So that's the first step. That's undoing the addition in this case. Well, the second step, right? Now we can undo the multiplication, which is 2x, right? So we divide both sides by 2. So we get from 2x equals 12. We divide both sides by 2, then you get x equals 12 divided by 2. So x equals 6. So this is kind of similar to the previous slide, but the first step, if there's no parentheses, which we're not going to be working with, is that you want to get rid of the addition and subtraction, and then you can get rid of the multiplication and division after all the numbers that have been added or subtracted been gotten rid of. So does anyone have any questions, or do they not understand the example? Yeah, Evelyn?
I wanted to ask, so if there was like a problem that wasn't addition slash subtraction, like say it was like decimals, a two-step equation with decimals, would you do it by PEMDAS or no?
Yeah, you would do it by PEMDAS. So that's why you would first start with like parentheses, exponents, but we're not talking about parentheses and exponents here. So yeah, you would, if there's like no addition and subtraction, then you would want to get rid of the multiplication and division. You want to kind of, when you're solving an equation,
get down, please.
you want to go
Get down.
of PEMDAS. So like, how in PEMDAS it's addition and subtraction is last, right? That's how you kind of combine everything. But for this one, you want to get rid of addition and subtraction first. But if there's no addition and subtraction, then you want to go multiplication and division next.
Thank you.
Yeah. Okay, any other questions? Okay, I'm going to assume not. And if you have any questions, feel free to ask. You can always put in chat. So that's two-step equations. So now we're going to practice these two-step equations. Yeah. So again, when you're done, like raise your hand or let me know if you want to explain. Like if you want to explain, raise your hand. And I encourage people who haven't spoken to speak. So I'll call on those who haven't spoken first, and then I'll call on those who have spoken afterwards if we've exhausted the list. But I'll give you guys a couple minutes, write these down, so that you can solve them. And yeah, when a majority of you guys are done, I'm going to let people explain. But yeah, if you want to explain, raise your hand. Okay. Is A-okay? Okay, so I don't think we have enough people who haven't spoken already who want to speak. So if you have spoken and you want to explain, just feel free to raise your hand. But if you're not done as well, that's okay. I can wait and we can discuss later. But if you want to explain, even if you've spoken or if you haven't spoken, just feel free to raise your hand. Okay, is anyone like not done with problems and doesn't want to see the answers? Okay, I'm gonna assume that you guys are either done with the problems or you guys want to see the answers. So in that case, Anwita, do you want to explain problem one?
Sure. So, first, I wanted to get rid of like the -4 from the left side. So I added 4 to both sides. So I got 3x equals 18. And then I divided both sides by 3. So I got x equals 6.
Okay, perfect. Shruti, I don't believe you've spoken, so do you want to answer problem 2? Yes, no, maybe? Okay, no answer, so I'm just going to move on. But Kanisha, do you want to explain problem 2?
Sure. So you subtract 7 from both sides, which you get y over 5 is equal to 17. So then you do 17 times 5 and you get 85. Y is equal to 85.
Not quite. You see how we're adding 7 here? Since we're
Yeah.
adding 7 here, you want to subtract 7 to both sides, right? To get rid of 7. So then if we subtract 7, what do you get on the right side? Yeah, so then then the left side is y equals 5, right? So y divided by 5 is equal to 3. So if y divided by 5 equals 3, what does y equal?
Y is equal to 15.
Yep, good job. That was good. All right. Okay, Priya, do you want to explain number 3?
Yeah. So basically, first I had to cancel out 2.5, so I subtracted 2.5 on both sides. So I had 4m equals 12, and then I just divided by 4, and I got 3.
Good job. That's good. And I'm Amrita, do you want to explain question 4 or do
I'll explain question 4. For that one, I'm going to add 2 to both sides. So now p divided by 3 equals 7. And then we multiply both sides by 3. So p equals 21.
Yep, good job. Okay, so this is going to be the answer slide of all the answers. So if you guys, do you have a question? Or okay, I'm gonna zoom out, but this is the answer slide. Does anyone have any questions about the explanations or these answers?
Can you go back to the question slide?
Yeah. This is the question slide. So I'll give you a couple more minutes to like write it down. And again, these will be posted on Google Classroom, so you're not missing anything.
Okay, you can go back.
Okay. But these are the answers which people just explained. But if you missed their explanation or you missed the final answer, then yeah, these are the answers. Okay. So that's that. We're gonna move on to inequalities now. So what is an inequality? Well, an inequality compares two expressions and shows that one is greater, less, or just not equal to the other. So here are some symbols that you should know. This is basically just like this is the less than sign. Second one is the greater than sign. So that would mean that one side is strictly less than the other. Now, it can't be equal to, can't be greater. The greater than sign means that one side is strictly less than, and that can't be equal to, not be greater. And then less than or equal to means that one side is going to be less than the other side, or it could also be equal to the other side. And then the final one is greater than or equal to, means that it's either greater than or equal to. It's pretty self-explanatory. Yeah, Evelyn?
For the less than or equal to symbol, I wanted to ask, does that work? So does it mean if you change the number? So if you were to have like 3 and you were to have maybe 3.5, could you say that it was less than or equal to because you would put the 0.5 to make it equal to?
What do you mean by that one? So like for
Like, do the numbers have to be fixed, and like do the numbers have to be fixed to get that sign, or can the numbers like move? Like, can the numbers change?
don't have to be fixed. There can be many numbers that fit the inequality. Hence why the answer for inequality can be like if you have like x is greater than 4, right? It's the final answer that you get. That means that any number greater than 4 works. It could be 4.1, it could be 5, it could be 100, it could be 4.0001. You know, there's many different numbers. So
Got it. Thank you.
yeah. So like we're going to look at this example, that was a really good segue into the example actually. So if we look at this example, you can kind of treat this like an equality, like an equation, where you have x plus 3 is greater than 7, right? So what numbers plus 3 is greater than 7? In this case, since we have a plus 3 on one side, then we can just subtract 3 from both sides, right? Like regardless, it's still going to be the same thing. So then you have x plus 3 minus 3, which equals x plus 0, is greater than 7 minus 3, and 7 minus 3 is 4. So that would mean that the final answer is x is greater than 4. But what does this mean, right? Like, just like we just said, this means that any number greater than 4 works. 4 itself does not work in this case, right? Because if x equals 4, 4 plus 3 equals 7. 7 is not greater than 7. 7 equals 7. So that doesn't work. Any number smaller than 4 also doesn't work. But if you have a number like 5, that works, right? 5 plus 3, 8, greater than 7. 10 also works. 4.0000 infinitely like 0.1, right? That's still greater than 7. So technically it still works. Any number greater than 4 works, whether it's an integer or not. But your final answer should also be in the form of inequality, like any number is greater than something, less than something, x is greater than or equal to something, etc. That's generally how to do it. Does anyone have any questions? Okay, I'm going to assume no questions, but if any questions come up, feel free to like ask. So this is solving inequalities. How do we solve an inequality? Well, we just gave an example, but for inequalities, you can kind of treat it like an equation, right? You want to isolate the variable through adding, subtracting, multiplying, dividing, just through your operations. But for inequalities, unlike equations, we have a special rule. If you multiply or divide by a negative number, then you have to flip the inequality sign. So what do I mean by flip the inequality sign? Well, if we have like negative, we can look at these examples. Like if we have negative 2x greater than or equal to 8, right? Well, we have to divide by negative 2. And negative 2 is a negative number, right? Because we multiply by negative 2, we have to divide by negative 2. So in this case, instead of we have x is greater than or equal to 8, in this case, we flip it so that when we divide by negative 2, we get the right-hand side equals negative 4, right? But instead of saying x is greater than or equal to negative 4, well, x has to be less than or equal to negative 4. And we have to do this type of sign flip. And if you're wondering, like, does this actually work? Well, we can test it, right? If x is less than or equal to negative 4, like we look at a number like negative 5, right? Well, negative 2 times negative 5 is 10, and 10 is greater than 8. So that means that works, right? And then if you have like a greater than sign, you're gonna have to flip that to a less than sign. And yeah, that's just flipping signs. So greater than or equal to flips to less than or equal to. And then greater than flips to less. And then less than flips to greater than. And less than or equal to flips to greater than 2. But if you're multiplying or dividing by a positive number, it doesn't matter, right? Like if we have x divided by 2 is less than 16, we can just multiply by 2. We don't need to flip the sign. X is less than 32. But you have to remember this special rule when you multiply or divide by a negative number. The inequality sign flips. So remember that. Does anyone have any questions? Okay. If not, we're going to move on to practice problems. I'm going to make this quick because we don't have much time left. I think I'm going to, you know what? I don't think we're going to have time to do this. But these problems will be up anyways. So you guys can practice this on your own if you guys need extra practice. And the answers are on the next slide. But yeah, I'm just going to quickly go over this and I think we're going to end it because we don't have much time. But yeah, if you guys want more practice, they're there. And if you have any questions about the practice, feel free to email me or message me on Google Classroom and I will try to answer. Or I'll answer them next class. But this is kind of just a fun thing to do, like graphing inequalities on a number line. I think they make it pretty easy to look at, but it's also kind of important to learn how to read graphs. So in this case, right? Let's see. You see open circles and closed circles, right? So for an open circle, that would mean that that's not equal, right? That's just like greater than or strictly less than. It cannot be equal. A closed circle means that it's a greater than or equal to or less than or equal to. So it includes whatever number that it's at, right? So if you have like an arrow to the right, that would mean greater. Arrow to the left, that would mean less than. So let's look at this example. X is greater than 2. Since we see that it's strictly greater, right? There's no equal sign here. That would mean that it's an open circle. So you can draw an open circle up 2. And then you can shade it to the right because it's greater. You can draw that arrow to the right, right? It's greater than. And on the left, I just kind of have this in variable form. But this is just like all the 4 different types, right? If A, which is some number, is less than B, right? Not equal to, then A can be any number to the left of B. So you draw this as an open circle and arrow to the left. If A is greater than B, then it's to the right, right? But it's still an open circle. And if A is less than or equal to B, then it's a closed circle, right? Because we have that equal sign, because A can equal B. But it's also could be less than, so it could be any number less than as well. So that would mean that we have an arrow to the left. And if A is greater than or equal to B, then you have an arrow to the right and then a closed circle. because a closed circle means that it could be equal to. And that is just graphing. Does anyone have any questions? Could be about graphing, could be about anything.
Can you explain about can you explain it again?
Like the closed circle, open circle, left, right arrow thing?
No, like why is there like an A like on top of the
Okay, so if A is less than B, right? So if we
Yeah.
just think about this, we can say, let's just say B equals 4, right? For simplicity matters. These are just variables, but B can be any number. So let's say B equals 4, right? For A less than B, that would mean that A can be, so A is less than 4. A can be any number less than 4, right? So
Yeah.
A is consistent of all the numbers to the left of 4 on the number line, right? Because
Yeah.
so that's why this arrow is basically A, right? Because this arrow is all the way to the left of the line. Every single number less than 4 or less than B in this case.
Oh, okay.
That's why there's that. Jessica? No question?
I was in the bathroom, so I don't know what you were saying that time.
Okay. I was trying to basically explain the graphing for this. So basically to graph it, yeah, I can say it this page as well. I'm just gonna say it this page while I answer questions. So how we want to graph it is that you can see that there's like an open circle or there's like a closed circle, right? So open circle means it's either strictly greater than or strictly less than. So there's no greater than or equal to, no greater, like less than or equal to, right? It's only greater than or only less than. And then a closed circle would mean less than or equal to or greater than equal to. So there is an equal to sign. So that's a closed circle. That's the closed circle, right? And then if the arrow is pointing to the right or it's shaded to the right, that would mean that's all numbers, that would mean that there has to be greater than, right? It's greater than or greater than equal to. But if it's to the left, that would mean that it's less than or less than equal to. So a way to think about this, right, is if you have x is greater than 2, right? Well, if x is greater than 2, x has to be greater than 2, no equal to 2. So that's how we know we draw an open circle at 2, that value. And then we have the arrow pointing to the right because it's greater than. Does that make sense?
Kind of.
Okay. So the way of thinking about this is just kind of thinking about how a number line works. So if we have a number line, right? We have a number like 2. Well, all numbers to the left of 2 is less than. All numbers to the right of 2 is greater than. And then you have 2, right? So if we want to show x is greater than 2, then we want to show all numbers to the right of 2, right? Because all those numbers are greater than 2. So x can be any number that's more than 2. X could be 3, 4, 5, on and on. But we want to show that. And how we show that is we use arrow pointing to the right, right? So then it points to all the numbers. This arrow will cover all the numbers that are greater than 2. But it cannot be equal to 2, right? So that means that we put an open circle at 2, because open circle at 2 means does not include 2. Does that make sense? More sense, at least?
Yeah.
Okay. If you have any more questions, you can ask me in a bit. But because time is almost up, I think we're just going to move to the review slide. Is anyone still taking notes or still need this slide? These slides will also be posted on Google Classroom, so if your notes are incomplete or if you need like extra time to look back on this, if it doesn't make complete sense, that's okay. Like you can always look back on this slide. With that being said, we're just going to go into our review and summary. So equations is statements of equality, right? There's an equal sign. Both sides have to be equal. And you solve it by isolating the variable. So you want to get, like, for example, x on its own. Inequalities is showing like some sort of comparison, right? Greater than, less than, greater than or equal to, less than or equal to. And you solve it like how you solve an equation. But you flip the sign when you multiply or divide by a negative. And then in order to solve an equation, you always want to use the inverse operation. So, you know, if you have an addition of 7, you want to subtract by 7. And then you want to, if you want to graph inequalities on a number line to show the solution to that. I don't think graphing is going to be on the homework just because, you know, I think that that's something that you can practice on your own. But yeah, that's about all. So if you guys have any questions, feel free to ask. But if not, that's it.